Hello viewers, welcome back to my channel. In this video, we'll be talking about the length of an arc. Okay, don't forget we are still talking about measuration. Now, the length of an arc, like I told you before, that if we have a circle like this, that an arc is simply when we have a radius like this, we have two radii this way. Okay, these two radii divides a circle into two major segments. Okay, two major segments called the minor and the major arc. From here to here is the minor arc, while from here, from this line, from this point to this point, is called the minor arc. The minor arc. Okay, why the one above, why the one above this one now is called the major arc. The major arc. Okay, and then to get the length of an arc, the length of an arc is simply theta over 360 times circumference of a circle. And circumference of a circle is what? 2 pi r. Okay? So theta over 360 times 2 pi r. That is the formula for the length of an arc. So let us solve some questions to help us understand it better. Okay? So the first question we're going to solve, question number 1 said an arc of radius, an arc of a circle, an arc of a circle of radius 8 cm subtends an angle of 85 degrees at the center of the circle. Okay, then I say we should find the length of the major arc. Okay, now then I say we should take pi as 22/7. Now you can decide to draw it so that you will understand what we are talking about. Now if we have this is the center of the circle, and these are the radii. Here is the radius they gave us is 8 cm. Here should be as well 8 cm. Now for the minor arc is this angle, which is 85 degrees. So for us to get the other angle here, is sum of angle at a point is 360. So we say 360 minus 85. Okay, so 360 minus 85, I'm having 275. So we tell them the length of an arc, the length of an arc, okay, is equal to what? Theta over 360 times 2 pi r. So which is something as saying theta is what? 275, because we are talking about the big one. We're not talking about the small one, the major one, over what? 360 times 2 times 22/7 times the radius here is 8. Okay, so if you do that, you're going to be having times 22 times 2 times 8. So the numerator gave us 96800 divided by 360 times 7. So I'm having 2520. So if we divide 96800 divided by this, so I'm having approximately 38.41 meter. Okay, if the other one is in meter. Okay, this one is in cm, so it's going to be cm. So that is that, and very simple. We move to the second question, question number 2. So question number 2 said that what is the length of an arc, which subtends an angle 60 degrees at the circumference at the circumference of a circle of radius 21 cm. Okay, now this is very simple. Solution. Okay, solution. This is very simple. Solution. Now they say that what is the length of an arc which subtends an angle 60 degrees at the circumference? So we don't use the one at the circumference. The one we use is the one at the center. So we say angle at the center is equal to what? 2 times that the one in the circumference. Okay, which will give you 120 degrees, because angle at the center is twice angle at the circumference. That is one of the theorems of a circle. Okay, don't forget that angle at the center is twice angle at the circumference. That's the reason. So we now tell them that what? That the length of the arc is simply what? Theta over 360 times 2 pi r, which is what? 120 over 360 times 2 times 22 over 7 times my radius here is 21. So the denominator is always 2520. Don't forget. So let us multiply the numerator. The numerator is now 120 times 44 times 21. So I'm having 110880. So if you divide it by 2520, you're having 44 meters, if the other one is in meter. Okay, cm, 44 cm. Okay, so you see, it's very, very simple. We move to the next question. The next question here is question number 3. So question number 3 said that the pendulum of a clock is 5 cm long and swings through an arc of 8 cm through what angle, comma, in degrees, comma, does the pendulum swing? Okay, so it is very obvious. They have given us what we need to know. So they gave us that we are looking for theta. So solution. So the length the thing moved. If we have that this is the pendulum, okay, this is the length, that is 5 cm, 5 cm. So it's going to swing like this, okay, and that is the length of the arc, which they gave us at what? 8 cm. So we tell them that the length of the arc formed is equal to what? Theta over 360 times 2 pi r. So the arc they gave me here is what? 8 is equal to theta over 360 times 2 times 22 over 7 times the radius is 5. Okay, so the denominator here is always 2520. So 8 is equal to what? 44 times 5. 44 times 5. I have 220. So I have 220 theta is equal to 2520. So therefore, theta will now be 8 times 2520 divided by 220. So I'm having 8 times 2520 divided by answer. So I'm having approximately 92 degrees, approximately. Okay, so we move to the next question. Approximately. So question number 4. So these things are very, very simple. So question number 4. So question number 4 said that a circle is divided into 2 sectors. A circle is divided into 2 sectors okay, in the ratio 3/7. Okay, sorry, 3:7, in the ratio 3:7. Okay, full stop. Then I say that the radius if the radius of the if the radius of the circle is 7 cm, comma, calculate the length of minor arc of the circle. Now, for us to get the theta is going to be, now, since it is shared into 3:7, solution, our theta will now be what? 3 over the total ratio is 10 times the total angle is 360, okay, over 1. So which will give you, that is for the small one. But if it's for the big one, it's going to be 7/10, then times 360 over 1. So that is our angle. So we have that is 336 times 3, because 0 cancels 0. So I have 108. So this is 108 degrees. So the length of the arc becomes theta over 360 times 2 pi r, which is what? 108 over 360 times 2 times 22 over 7 times the radius there is what? The radius is 7. Okay, so this will now give us 108 times 44 divided by 360. So I have 13.5. So this is 13.2, sorry, 13.2 cm. Okay, so we move to the next question, question number 5. See, all these things are very, very simple. All you need to do is to apply your common sense. So question number 5 said that in a circle, comma, an arc of length 110 cm, okay, subtend an angle of 210 degrees at the center. Then I say find the radius of the circle. Okay, now this one is very simple. Solution, we know that the length of an arc is equal to what? Theta over 360 times 2 pi r. So the length of the arc they gave me is 110, is equal to, the theta is 210 over 360 times 2 times 22 over 7 times our r. So therefore my r will now be 110 times 360 times 7, then divided by 210 times 2 times 22. So if you do that, immediately you are going to be getting 110 times 360 times 7. So I have 210 times 2 times 22. So I'm having 30 degrees. So 30 cm, sorry. Is the other one in cm? Cm, so 30 cm. It's very simple. We move to question number 6. So question number 6. Right? Question number 6 said an arc of a circle radius 14 cm, comma, is 18.33 cm long. Okay, then I say we should calculate, then correct to the nearest degree, okay, the angle which the arc subtends at the center at the center of the circle. Okay, so this is very simple. Solution: what do? We have that the length of an arc, length of arc is equal to what? Theta over 360 times 2 pi r. So they say that an arc, the radius is 14. An arc of circle with radius is this long, so that's the length of the arc. So I have 18. So I have 18.33 is equal to what? Theta over 360 times 2 times 22 over 7 times the radius here is 14. So therefore my theta will now be 18.33 times 360 times 7, now divided by 2 times 22 times 14. So if you do that, you will be having 18.33 times 360 times 7. So I'm having 44 times 14. So my answer approximately is 75 degrees. Okay, that is that. We move to the next question. Question number 7. See, all these things are very, very easy to solve. So we're going to solve just 12 questions. Question number 7. So question number 7 said the diagram shows an arc MN of a circle center O, comma, with radius 10 cm. Then I say if angle MON is equal to 72 degrees, they say we should calculate the length of the arc. Then we should correct to 3 significant figure. Solution. Okay, sorry, look at the shape they gave us. They gave us something like this. Sorry, I'm not good at drawing. This is my M, this is my N, and this is O, and this is 72 degrees. Okay, now this is very simple. We'll tell them that length of an arc is equal to theta over 360 times 2 pi r. So the length of the arc, did they give it to us? Okay, that's what they say we should calculate. So this is 72 over 360 times 2 times 22 over 7, then times my radius. My radius is where is the radius? Radius is 10. So I'm having so 72 times 2 times 22 times 10 divided by 2520. So I'm having two significant figure. So first of all, it is 12.57142857. So this is equal to approximation to 2 significant figure is 1 2, that is 12. So this is up to 5. Come here, you call it 13. So it is 13 to 2 significant figure. Okay, so they say 3 significant figures, so it is 12.6. 1 2 3. This is up to 5. Call it 1 and come here. So 3 significant figure. We move to question number 8. All these things are very cheap question. So question number 8. Okay, question number